Everyone, this is Ankush here. So today, this is the very first video from the graph series. Today we are going to solve the problem counting holes. You are given a map of building and your task is to count the number of its holes. The size of map is n cross n squares and each square is either floor or wall. You can walk left, right, up, down to the floor squares. So what you have given a grid of n cross n and hash represent the wall and dot represent the floor. What you have to do, you have to find the number of rooms. You have to find number of rooms, right? So this is one of the room, right, in which there are two floors, and there is another room, and this is another. So the number of rooms in this grid is the number of rooms in this grid are three, right? Perfect. So how could you find that? You can move from floor to floor, right? You can move from floor to left, right, left, up, and down, right? And if there is no floor in any of the neighbor, if there is no floor in the neighbor, so you couldn't make a move, right? Because there is a hole, you can make a move if there is a floor, right? Perfect. So what we are going to use? We are using BFS to solve this problem. Let's understand how BFS does work to solve it. So you have a grid, right? And we maintain a visited array, and we have a queue in which we store the position of the floor, right? Such that 1 comma 1 and 1 comma 2 like that, right? Perfect. Now we start with the very first position, that is 0 1 0 0, and we start moving, and we saw that there is only four, right? There are only holes, so we just continue. So if we found the hole, we just continue, and second there is a hole, continue, and we encounter a flow, right? We encounter flow. So what we have to do, that we have to travel all the flows reachable from this flow, right? So there is only one floor. So you travel all these floors. So there is a room, right? To go from the another to go to this floor, you have to there is another room. So you have to increment your count of room, right? So we maintain a count is equals to zero, right? And if we encounter a floor that is already visited, then we have to also continue, right? Then we have to also continue. So it is not visited right now, right? That is 1 comma 1 is not visited. So what we do, that we put it into the queue, that is 1 comma 1, and mark it as visited, and mark it as visited, right? Perfect. Now uh, from this floor we can go to this, we can go to this, we can go to here, we can go here. So we cannot move here, right? So what we could do, that we put 1 comma 2 in the grid and 1 comma 2 in the queue. We put 1 comma 2 in the queue. Now we try to travel, and we can go here, we can go here. So this is already visited, so we do not put into the queue again. And now the queue will be empty, and we encounter first. So we have to increment the count when we put 1 comma 1 in the queue, right? Now we're done with this. Now we go to next uh, next position, that is this. We where we stop here, right? We encounter this and we put it into the queue. Now we encounter this. This is already visited, market visited. This is 1 comma 2, market visited, right? So we encounter this. So this is already visited. This is the whole. Then we encounter another floor. So we have to travel all the floor which is visible from this, right? So we put it into the queue. That is 1 comma 4, right? 1 comma 4, and from 1 comma 4, market visited, 1 comma 4, market visited. And the next we have to insert 1 comma 5, right? 1 comma 5 and 2 comma 4. So we inserted it 1 comma 5 and 2 comma 4. Then from 1 comma 5, mark both of them visited, 1 comma 5, 2 comma 4, market visited, right? Now, but from 1 comma 5, we can go to 1 comma 6, right? So put 1 comma 6 q, and we have to increment the count again because we encounter again right? So we have to increment the count, right? Perfect. Now from 2 comma 4, 2 comma 4, we can go to the 3 comma 4, right? Because this is already visited, 1 comma 4 is already visited, so we can not go here. So from 2 comma 4, 2 comma 4, we can go to the 3 comma 5, 3 comma 4. Now from 1 comma 6, we can go to the 2 comma 6, 2 comma 6, right? And mark 1 comma 6 also visited. From 3 comma 4, we put 3 comma 4, so mark it visited, 3 comma 4 visited. 2 comma 6, 2 comma 6 also in the queue, mark it visited. So from 3 comma 4, we can go to the, from 3 comma 4, we can go to the 3 comma 5. So mark it visited, 3 comma 5, mark it visited, right? From 2 comma 6, we can go to the 3 comma 6, right? And mark it visited, mark it visited, right? And this is empty now. Now we are done with all of this, right? We mark all of them visited. So we visit all these floors, right? So next we are here. So this is visited, visited, continue, 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 continue. This is also visited, then continue, 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 continue. This is whole continue. Then we encounter a floor which is not visited till now, right? That is 3 comma 1. 3 comma 1 is not visited. So put into the queue, put it into the queue, and mark it visited. That is 3 comma 1, and mark it visited. So from 3 comma 1 we can go to the 3 comma 2, then mark it visited. 3 comma 2, yes, mark it visited, and then we are done with this also, right? And the queue is empty, right? And we encounter 3 comma 1, right? So increment the count 3. Encounter the another floor that is not visited till now, so mark it visited. So then where we are here, that is visited, whole continue. This is also visited, then just continue. So our answer is 3. So this is how we can apply breadth first search, BFS, right? So the intuition is when you encounter a visit the floor which is not visited, then mark all the floor visited, all the reachable floors from the that floor. So you mark it visited and you are done with this, and you increment your count to 1. Next, you encounter this which is not visited, then you visited all the reachable floors, right? Uh, and mark all of them visited and increment the count, that is 2. Then you encounter another, then mark it all visited, then and increment the count to 3, right? So this is how you can do your BFSR. Now, how you can move to left, right, up, and down. So from X comma Y, you can go up, you can go left, right, down. From up, you can uh, do X minus 1 Y. From down, you can go X plus 1 comma Y, right? And from right, for the right one, you can do X Y plus 1, and for the left one, X Y minus 1, right? So for left, you have to do minus 1 0. You have to add X and X. You have to do minus 1 from the X and plus 0. And from for the up, for the down, you have to do 1 comma 0. So for the left, you can do 1 comma 0 comma minus 1, and for the down, you can, for the right one, you can do 0 comma 1, right? So you maintain a array of this one, that is direction of X and direction of Y, that is minus 1 1 0 0 0 0 minus 1 1. This is something you can do, right? And you have to uh, traverse in all of these directions, right? If you encounter a wall, just continue. If you encounter the floor that is not visited, that is not visited, right? So you push it into the queue, and you just increment the count in very first time you got the floor, right? So this is something how you can do your BFS search. So let's try to code it. So let's try to code it. Uh, this is our direction with this, right? And let's we have a n cross m grid, and, and uh, next define the vector of a string. We have a of size n for in that equals to 0, I less than n, plus a ai. These are input, and now let's define visited array. The vector of int visited of size n comma of int n comma 0. These are visited array. Perfect. Now we have to declare a queue of pair int comma int, right? Then we have to traverse in the grid. So j equals to 0, j less than n, j plus plus. Now, if it is ball, if it is a ball, then we have to continue. Ai j, if it is a ball, then we have to continue. And if it is visited, if it is a floor and it is already visited, then we have to continue. Perfect. Now, if it is not, then we have to push into the queue. Queue dot push I comma j, and we have to mark it as visited, and we have to increment our count. Let's maintain a count variable. Count equals to 0. Right, perfect. Now next we have to travel all the reachable floor, right? While queue not empty. Our is equals to queue dot front dot first, and we have a y equals to queue dot front dot first dot second. Right, perfect. Now next thing is we have to travel in all the four direction. K equals to 0, k less than 4, k plus plus, and our next direction or next x coordinate is uh, x plus d direction of x, and k, right, and is equals to y plus dy of k. And next we have to check if it is in the bound or not. If nx is greater than equal to 0, and nx is less than n, and ny is greater than equal to 0, and nm is next y is less than m. If it is in the bound, and if it is not the whole, that is, it is the float. So we have to check a of nx and y is equals to is not equals to 1, and it is not also visited. So visited of nx and y is not equal to 1. If it is not visited, not the whole, then we have to just push into the queue. Push into the queue and x and y, and we have to mark it as visited, right? And next we have to, yes, we are done with this, right? And our answer is our count, right? This is the code. Now let's try to check it that we have done correctly. Yes, it's correct. This also looks great. Perfect. Yes, it looks fine. Let's try to run it. I yes, we forgot pop out. After we have to pop from the queue. Try it again. Yes, we got the right answer. That is it, right. So the time complexity of this code is going to be n cross m, and the space we are using n cross m visited array, right? So I hope you understood it. Thank you.